Good afternoon. Today I'm going to discuss about the course project for CS6201 Discrete Structures 2. So the requirement is to solve the problem provided on the course project. So create a video presentation while solving the project. So first is the adjacency matrix. So I'm gonna solve this while making the video presentation. So first is get the adjacency matrix representing the graph here. So the graph is this one, the map. Then there are plots, coordinates for the addresses. The best thing I can do is get this graph, then put it in the paint first. Then from there I can assign the value so it will be easier for me to uh, so based on the numbers, so Del Nasha 4 Park is 1, 4 Park is 1, then Nia Village is 3, Nia Village is 3, then San Pedro 6 covered court is 2, farmers 2, then Napocor Village covered court is 9, then Napocor Village is 5, then Sci-Tech Chapel is 8, Sci-Tech Chapel is 8, then Himalayan Filipino Cemetery is 7, San Pedro B Park is 4, San Pedro B Park is, where's it? San Pedro 4 is intersection, then Maria Luisa Townhomes is 6. So this is our coordinates and vertices. So for the adjacency matrix, the was provided by the course project. So here it is, the table. So first we need to check if there's a loop on our graph. So we don't have. So we will set the diagonal to 0. Then 1 to 2 is 1. 1 to 3 don't have. 1 to 4 don't have. 1 to 5 don't have. Then 2 to 3 and 2 to 9. 2 to 3 and 2 to 9. Everything will be 0. And 3, nothing. Then 4 to 8, 4 to 7, 4 to 5. 4 to 8, 4 to 7, 4 to 5. Then 5, nothing. Points to nothing. Then 6 is the end. Points to nothing. 7 points to 6. 7 points to 6. Then Then 8 points to nothing. Then 9 points to 4. So that's our adjacency matrix. Okay. Now we go to activity number 2 for the probability, possible outcome, and favorable outcome. So first, there are three requirements: tossing a coin, throwing a dice, and taking cards from a deck. So first, we will discuss about the tossing a coin. So in tossing a coin, we have two faces, heads and tails. So two faces, heads or tails. So our possible outcome is two. So the favorable outcome for heads or favorable outcome for tails is 1. So for the 1 for heads and 1 for tails. So based on our formula of probability, so it's the favorable outcomes versus over the number of possible outcome. So favorable outcome probability for the heads is the favorable outcome of 1 over possible outcome of 2. Therefore, we have 1 point 0.5 possibility or one half possibility or zero point 0.5 possibility probability of getting heads. So same with the tails. So with the tails is there are 1 favorable outcome out of 2 possible outcome will be 1 or 2 or zero point 0.5 probability of getting. Now we will move with the throwing a dice. So in throwing a dice, we have 6 sides. So I have 6 sides of dice. So how many possible outcome? So we have 6 sides. It will be 6 possible outcomes. 6. So the favorable outcome for drawing or getting 1, 2, or 3, or 4, 5, 6 is since there are 6 faces of each side, favorable outcome of getting number of each side is 1. Uh, so based on our formula, the number of possible outcome, the probability formula is the favorable outcome versus uh, favorable outcome versus possible outcome. So, for example, we want to get number 5. The probability of number 5 getting from the throwing a dice is 1 over 6. So we have 1/6 probability of a number from a dice. So what is other probability? Let's say even number. So for even number, uh, how many even number for our dice? So we have 3. So how many favorable uh, even number that we can draw? So it's 3. Even number will be fav- favorable outcome over possible outcome. It will be 1 or zero point 0.5 possibility probability of even number. So same with the odd number. Odd number is three faces of the three sides that have number, odd number. So then it will be zero point 0.5 probability of odd number. Now we move on to the cards. So uh, there are different uh, if you want to get different probabilities for getting a card. So we have let's first get the number of cards on a deck. So we have uh, taking cards from a deck. Taking cards from a deck. So how many cards do we have from a deck? We have 52 cards on a deck. So uh, the possible outcome is 52. So it will be the requirement or different requirement if what do you want to draw on the card. So for example, we want to draw a specific three of spades, five of hearts, king of hearts, or there are cases that you want to draw a red card without specifying which is a number or a face card, or you want to draw an aces. So it depends on what's the requirement of what we're asking of which probability. So let's do the uh, probability first for the one number. So if we want to draw a three of hearts, so how many probable outcome? So there will be only one probable favorable outcome of getting a three of hearts. So our probability for getting a three of hearts card probability will be 1 out of 52 decks of card of getting a three of hearts. And as I said, we have other requirement like how many probability of getting a red card. So how many red cards do we have? There are hearts and diamonds. So there are 13 hearts from ace to king, then 13 diamonds, ace to king. So there will be 26 red cards. So probability of getting a red card. So there is a favorable outcome of 26. So our probability of a red card will be 26 out of 52 decks, which is also equal to 1 half. Probability of getting a red card. So now, let's say they want to get the probability of a king, a face with a king. So let's, how many kings do we have? So we have a favorable outcome of 4 kings. So our probability formula will be Uh, there will be four kings out of 52 cards or 1 over 44, 48, 13. 1 over 13. Correct? Let's try. Ah, sorry, 13. So the probability of getting a king. So as I said, it will be a case to case basis on what do we want to draw, or what's the requirement to draw uh, from the deck of cards. So that's it. So this is the course project for the CS6201 discrete structures. Thank you.